What do you do when you need to machine custom aluminum parts, but you don't have a CNC machine? That was the exact situation I found myself in a little while ago. I was in the middle of a robot build for my startup and specifically needed to machine aluminum for a gantry. The problem? I was still a student. I didn't have a garage or permanent space, but I needed a CNC machine, and maybe one that was portable enough to bring into a shared lab and not get into people's way. And just as importantly, I needed something I could pack up and transport with me when I finished my studies. My initial research led me to some pretty impressive machines. I was looking at options like the Sheriff DMC2 Mini and the Lagmeyer MR1. I think these are great options, and if I had a solid foundation and a dedicated spot to put these machines in, either of these would have been an amazing choice. They're rigid and powerful. But for my specific temporary situation, they're a little too permanent. I had to accept that I needed to trade off some of that rigidity for something I could realistically transport and move by myself. And that's when I stumbled upon the Lunyee 3018 Pro Ultra. Now, I know what a lot of you are probably thinking.
A 3018 for milling aluminum? Whoa, man, that's wild. You know, that reminds me of this one time, my mom's boyfriend, the one who pawned my watch, not the one who got arrested for grand larceny, he tried to make a custom gear shift knob for his car out of an aluminum can. He didn't have a CNC, so he used a drill and a butter knife. The thing looked horrible, and when he tried to install it, he broke the whole gear stick. My mom got so mad she threw the whole toolbox at his car. She said, mishandling tools is a betrayal of trust. He had to drive to work in first gear for a month. It was hilarious.
And here's what I have to say to that. A few things made me decide to take the plunge. First, my background is in robotics and I've worked with CNC machines before. I felt comfortable with the idea that I might have to tinker with it, upgrade it, and maybe fix it, or dial in performance if I needed to. And second, this was the real deciding factor. The Amazon return policy. Jeff Bezos gave us the return policy of the gods, making this a low-risk gamble. If the machine was a total disappointment and couldn't mill aluminum, I could just pack it up and send it back. So I pulled the trigger and bought one. When it arrived, the machine came in a big and heavy box. The packaging was good, and it was easy to remove the parts. Everything was protected by foam. I was surprised by how easy it was to install. All I needed was a screwdriver and a metric bit set. Unfortunately, I do have to mention that they use small M2 screws to secure the anti-vibration feet to the machine, as well as securing the power supply to the Y-axis of the gantry. These screws are easy to strip, and even being careful due to manufacturing defects among some of the screws, they're very easy to strip and they're very easy to lose as well. So you do have to be careful. I wish that they used M5 screws instead. The frame of the machine is solid, and through the entire time of using this machine, I never encountered a time when the gantry was not able to take the force of the spindle cutting into the aluminum. The machine has been banished to underneath the desk. It's important to note that the wires are not shielded, so there is a potential for EMI interference and missteps in the NEMA 17 stepper motors. To help mitigate this, you can place ferrite beads at the start of the motor drivers and the end of the motor wires that lead up to the motor. So after testing the machine and making a few practice parts, I encountered a problem. So 2:55 a.m. and I just put in a new program. The old one finished, but it didn't cut it out all the way, so now I have another one. This one should be 100% accurate, and then these two are other new parts that I can machine in this plate as well. I'm gonna leave this in overnight. I increased the settings a little bit. Hopefully it doesn't blow up. It should be fine. It's a brand new day. Let's see how the machine performed. So at first I walked into the lab and I was like, okay, everything's covered in chips. I couldn't see the cut, so I was like, okay, I mean, it's probably underneath the chips. I see the holes. That looks good. And then I walk over here, I'm like, oh, that does not look good. So the machine was programmed to come around here, and then I guess it touched the clamp. It cut into the clamp, and then it plunged about 4 millimeters deep, came back out, continued with the program, and then it came over here. It was supposed to come down 0.2 millimeters for every pass. Instead, it plunged down about 4 millimeters. And after that, I guess something happened with the power supply, because the power supply no longer turns on. Usually there's like a little green light over here. There's no humming, there's no green light. The board is still okay. It's still connected to my laptop and there's a little light there. The power supply is fried, and overall, if this didn't happen, there's a possibility that it would have cut pretty well, because the step over was pretty conservative, and the program that I did before the cutting, well, technically before the contour, this was the cutting. It did that pretty well. This is pretty nice. It's a little it's not perfectly smooth, but it's all right. I measured these holes. These are 5 millimeter holes, but they measure out to be 5.4 millimeter, which is fine for my application because they're through holes. Now I'm probably going to reach out to Lunyee support, and I'm going to see what their options are for the power supply. Also, I know that this is a toy for aluminum cutting, especially for 3/8 thick aluminum. This is mostly for wood. I'm sure this machine is great for wood and for thin stock of aluminum, but I'm going to replace the machine. I bought it off Amazon because Amazon could ship it out faster than Lunyee could, so I got the machine within 2 days of ordering it, and I'm going to replace it with Amazon, get the refund, and I already bought the Lunyee 4040 Turbo. I know that this is a toy for cutting aluminum, but it's what works for me. Right now I'm going to be leaving the university soon, and I don't have I can't be carrying an engine hoist and lifting a PM30 out of the lab, going into my car, taking it home. Once I have a more solid foundation, then I'm going to invest in bigger machines, but for now, these router type machines is what works for me, especially for when I need to cut motor brackets and brackets for joining other parts together. So yeah, I got the 4040 Turbo. I got that one because of the larger workspace. I have a little plan that I'm going to make another video about, but I want to build a CNC machine. And to build a CNC machine, you need to have a CNC machine or a milling machine. So I'm going to use the Lunyee 4040 Turbo, if it works out, to make a CNC machine, and also it has a better bed than this machine over here. This machine has pre-drilled holes, but there's nowhere to square your stock. So if I put a 1 to 3 block, there's nowhere to put a 1 to 3 block here and then align it with the stock. So what I'm going to do is, with the 4040 Turbo, their bed is made with T-slot extrusion, so you can slide in your clamp using a T-nut, and that would help me align my parts much better than what I could align with just these predetermined holes. And I'll show you how that cuts in another video. But don't let this easy fix scare you away from the machine. You can buy a nice power supply off Amazon and use that as a backup while you're waiting for a replacement from Lunyee, just in case yours breaks. Customer support was really helpful to me, and they sent out a replacement once they confirmed that it was the power supply's fault and not the spindles or the boards. In case your power supply breaks and you need to use another one, it's really easy to set up. Here's what you need to do. First, take an AC power wire and cut off the female end. Next, remove 10 millimeters of the outer casing from the wire, and then strip 5 millimeters from the ends of the white, green, and black wires. Connect the black wire to the live on your power supply, the white wire to the neutral, and the green wire to the ground. Next, grab a multimeter and test the voltage. Set the meter to DC volts and then place the prongs to the positive and to the negative terminals. Make sure that the meter reads between 47 and 48 volts. There might be a little knob so that you can crank up or lower the current and the voltage. I would not recommend testing the current because not all multimeters can handle the amperage, but by cranking the current to the max, you've basically ensured that the power supply can provide as much juice as a spindle needs under a heavy load. Okay, it's been 2 days, and actually I got a replacement power supply from Amazon. So the Lunyee 4040 Turbo, that was supposed to be here today on Tuesday, but it got delayed for 2 more weeks. So I was like, okay, well, I need to make some parts, and I don't have that much time, so I'm going to just order a power supply while Lunyee is also shipping out the power supply that they promised me. Oh my gosh, this light is so bright. Freaking. Staring at the light from my camera is actually making me blind. I have like a little spot that I can't see now. Anyway, so yeah, I got this power supply. It's 48 volt, 600 watt power supply. I wired it up here. So over here I took a cable, I cut the wires, removed the casing. I feel like I'm talking about a sausage. And now it works. Okay, so I just got back to the lab. Let's see how the cut is. It looks pretty nice. A lot of dust. Unfortunately, I wasn't here all night, so I couldn't take away all the dust. This is one piece I needed to get. And then here we see the tabs. This I can just cut out using the bandsaw. This is a failed part, but I want to see, maybe I can find a use for it. So it came out to 3 inches, 938 thou. Very nice. And then in terms of width, it came out to 2 inches, and it's off by 6 thou. Not bad.
I hate updating my software! I hate updating my software! We've got you surrounded. Accept our terms of service.
The software that we use for the Lunyee 3018 is called UGS, or Universal G-Code Sender. And now when you're going to be doing a live zero, it's really important to account for the diameter of the bit. So first, before we even do that, you would start the spindle by using command M3, and then S for spindle, and then the amount of rotations per minute. So I'm going to do 10,000 rotations per minute. And now the spindle is spinning. And if you want to stop the spindle spinning, you type M5 in the console. Also, I just want to show how to set up the probe module. So you just connect the wire to the bit, and then you have this under wherever you would have the spindle touch down on. And then inside UGS, you go to plugins, Windows, and then plugins, and then you go to probe module. In probe module, you would set the thickness of your probe over here. So mine is 1.52, and they're all a little bit different, so you should measure yours and then enter the correct value here. And then you want to set the probe distance / direction to about -30 to -50, because if the default is 10 millimeters, and if you set the probe to 10 millimeters and the spindle is like maybe 15 millimeters above and it reaches the end of the 10, it's going to send off an alarm and crash the system. So you want to have a safe amount of travel distance for your spindle. So now we can press probe and 0, and then that's going to make contact and then do a slow tap. And then that sets our Z. For squaring up the stock to the workpiece, I use 1 to 3 blocks. So I set the first 1 to 3 blocks right here, and then the second one right over here. And before I actually tightened the clamps, I made sure that this edge of the part was was flush with this. And then I tightened the clamps, and then I removed these. Now what we're gonna do is set the 0 of the X and the Y. So this would be the X and this would be the Y. And we also have to account for the diameter of the 4mm bit. So it's 2 millimeters in diameter. So when we actually square, or when we set the 0 for the X or the Y, we have to account that it's actually -2, because we're counting from, well, I'll just show you, but we're counting from like the center of the bit and not the part that touches. So it would be -2 when it touches the side of the stock. So over here we want to go into the console, and then we want to type M3 for spindle start, and then S for spindle, and then you can put 8,000 rotations per minute. I'm going to use 10,000. And now the spindle is spinning. Now we want to align, so we're going to set the millimeters per, I think it's step. So we're just going to set the step to 10. Actually, we could set it to lower because it's already close to the edge of the workpiece. So I'm going to change it back to 5, and then let's lower the Z-axis. The thing with the Lunyee 3018, the Z-axis is so slow, and mine also screeches a little when it moves down. The Z screeches a little, so we can set it down one more time. And now we want to lower the step size so we don't crash the spindle into the stock. So we can put it down by 1 millimeter. And now when we move the spindle, it moves over by 1 millimeter. So now that it's very close to the part, we want to lower the step size even further. So we can set it to 0.1. And then when we go into the negative direction, we want to use our ears and hear when it makes contact with the stock. And when it makes contact with your stock, that's when you're going to zero. Alright. So now that's going to be your 0 right here. 0x. But now you have to remember that this is only the edge of the bit. and it's not actually the center of the bit. So the center of the bit is 2, if the whole bit is 4 millimeters, the center of the bit is 2 millimeters. So we want to set -2. And now we want to move back out. We can set the step size to be a little larger. Now we can raise the Z, decrease the step size. And now we're going to listen with our ears when the spindle makes contact. Now that you know that it's pretty close to the edge, so we can even lower, if you want higher precision, you can lower the jog. Okay, now that we saw that material fly off, that would be our 0. A good way to make sure that you did your calibration right is to go to Toolbox and then hit Return to 0. This will move the bit. So, for example, my bit is 4 millimeters in diameter. So it's going to move 2 millimeters in the Y and then 2 millimeters in on the X. And so now it's 2 and 2 and then 2 and 2 outside. If you did your origin in your CAD program as the bottom left corner, then, and you had a 4 millimeter bit, then if you did everything correct, it should move 2 millimeters in on the Y and then 2 millimeters in on the X. So this is a good way to verify and make sure that you did everything correctly, because you can keep doing return to origin. Like if you see that your spindle or that your bit is on the outside part of this, that means you need to go in -2 millimeters for a 4 millimeter Endmill. Overall, I give this machine 9 out of 10 spicy sausages for cutting anything softer than aluminum.
Squiggity, squiggity, squig, squillium, squiggity, squiggly, squaggity, scoogity.
And 8 out of 10 smoked beef links for cutting aluminum.
1, 2, 3, 4, 5, 6, 7, 8.
A major reason why it scored so high was purely the affordability. Also, had the power supply been more reliable, this machine would have scored even higher. I think reliability will only increase in the future, and hopefully they will use a higher quality power supply. Let me know if you'd like to see the follow-up of this video showing off the big brother of the CNC machine, the 4040 Turbo, or an in-depth guide on making parts in CAD.
Hey, Dr. Pepper Peter here. The software I use to design parts is called SolidWorks.
Manufacturing them in CAM, and then getting it on the CNC machine. Also, consider hitting the like and subscribe buttons to be notified of new videos. Peace.